Did you say and Thursday? Okay, anyway, besides that, I also did a problem wrong. So when you do a problem wrong, then it takes you 20 minutes to unwrong it. So I put these specifically. I just did one thing wrong. I kind of felt like it was wrong, and then it felt right. So there's a lesson. But then I looked and it was wrong. It's coulombs. Does it say Columbus? Oh, that's funny. What the? Did I do it wrong on every slide? Okay, I don't know. I must have been so wrong it autocorrected. That's funny. Oh, whatever. I don't really give a crap. It's coulombs. No. All right. So we did this problem, this one, and I just made one little mistake, and whatever, no big deal. So when we do this, you need to convert time to amps, and amps to coulombs by converting the times to seconds and multiplying by the amps. We did it in the all-in-one picket fence, and that was fine. That wasn't what I screwed up on. But it probably is cleaner and easier if you just take your amps and multiply it by time, and that will give you coulombs. And then number 2, you start with that number you just solved for as coulombs. And then this is where I messed up. It says use Faraday's constant to eliminate coulombs and get to moles. Then use the moles of electron transferred to moles of atoms ratio. Then use the grams to mole ratio to solve for grams. All right, so I had Faraday's in here. It's hard to explain what I did wrong, but just go with me here. So the first step is to take well, there might be more than those, I don't know, but we'll just go. I'm used to regular chem. Calculate the number of grams, so we come up here, convert time into amps by multiplying amps times seconds, essentially. So 1 hour is 3,600 seconds. Is everyone okay with that? Okay, my amps is 5. So the first thing I need to do is multiply 3,600 times 5. Is that 18,000? Okay, so that's 18,000. All right, and that would be coulombs. All right, that's an amount of actual charge. Okay, it's equal to, like, it compares the electrons transfers per mole, which is really convenient. All right. Then we use Faraday's constant, but we don't use Faraday. That was where I screwed up. So it's 96485 coulombs per every 1 mole of electrons. And this is where I had my problem. I had that per 3 Faradays. And mole ratio twice. All right, so that's moles of electrons. Okay, and that's Faraday's constant. It's how we can get coulombs to moles of electrons. Now, what am I solving for over here? Grams of zinc, right? All right, so I need to know the moles of electrons transferred. And we don't need a ton of chemistry knowledge here. If we just know that zinc is 0 as a pure element, and what is it in a compound, this will tell you. It's a positive 2. So all we need to know is the difference there is that there are 2 electrons transferred for every 1 mole of zinc. Do you understand like that? Every zinc atom has to lose 2, so every mole of zinc loses 2, or for every 1 mole of zinc, 2 moles of electrons are transferred. Okay, and then I'm just spinning these steps right here. That was the moles of electron transferred to moles of atom ratio. That was this piece. Then use the grams to mole ratio to solve for grams. So for every 1 mole of zinc, I have, from the periodic table, 65.4 grams. And then we would go from there. So I typed that in. If I did it right, I got 6.1 grams. Will someone check my math? Okay. Now, once again, and I don't know, I didn't even post the video Friday. I still will, but the mistake I made there is I was putting the 2 in here and later putting the 2 down here. So I was using that twice. So it wasn't a huge mistake, but it was definitely not the right answer. Okay, so pretty similar. Try and follow the same process. All right. So it's really pretty. Very symmetrical. So you take this and you convert it to 3600 seconds again. Times it by 10, right? And you get that number, correct? All right. Then the next step, what number do we put down here to get rid of C's? All right, and that's for every 1 mole of electrons transferred. This time it's Al, so it's not 2 down here, it's 3. Is everyone okay with where I get that value from? Okay. All right, and that's per 1 mole of Al. All right, so down here I have 1 mole, Al, 27 point something maybe, grams of Al. All right, either way, and we got 3.36, 35. It just depends on what you did here. I probably don't have one of those plugged in there right now. They're a different shape than the other ones. Okay. All right, we okay with that? I'll give you 1 more just to hammer that through. Uh-oh, hold on. All the answers are there. You gonna close your eyes? Oh no, so much stress. Okay, oh shoot, I can't do that. Oh no. Oh, I never wrote the answer, so I guess it doesn't matter that much. Oh, that was cool. Oh, that's weird. I don't know what's happening. I don't know, but I like this a lot. This should be on the satisfying, whatever you kids watch nowadays. Yes. Woo. Woo. Boom. I really enjoyed that. Oh, I gotta focus. I'm gonna get distracted again. All right. It looks like I just had the time. Sorry. So thank you for helping me there. It was the time times the amps. So I did that value. So it was the time times this gives you this. 9.6. No. I didn't tell you anything wrong. I just hadn't done it yet. Yeah, that's the time. That was correct. But then you had to multiply it by 7.6. All right. And then your coulombs to end up in moles. Your 3 moles because it's Cr plus 3. 1 mole of Cr, 1 mole of 52. And we ended up with a big number, 250 something. 235-ish grams. Emily didn't like the size of that number, but it was just fine because 2 days is a pretty long time to run a current, right? And 7.6 amps, that's not like that much, but it's a fairly sizable amount of amps. So, anyway. What's that? Yeah, if they were using batteries. Okay, are we all right with this? Okay. There's a few more just like it, but we can call it good. So tomorrow I'm going to give you a test/quiz. Let me pull those 3 questions up and show them to you. Sound fair? Oh, shoot. It's a picture. It's a diagram. It's a thing. So give that a shot for the next couple minutes and see if you can do it. Good. I switched it up. All right. What happens at the cathode? It's reduced and it's oxidized, right? Okay, which one was reduced? Copper is my cathode. How come? All right, it has a more positive electrical potential. That plus sign's in a dumb spot. All right, and then zinc must be my, was it zinc? Yeah. My anode. All right, because it had a less positive one. What directions are electrons going to flow? All right, from anode to cathode, correct? Okay. All right, in my salt bridge, where's what going to go? All right, so my cation ions go this way, and my anions go that way. Fair enough? There's nothing else you need to label here. Okay, well, that's, no, you don't need that. Okay? Thank you. It might ask you, this doesn't, but on the AP test it would say, what is the voltage of this cell? Yeah. Cat minus an. One was 0.3 something, one was 0.7 something, right? And so 1.1. Okay, fair enough. Okay. Number 2, balance the following oxidation reactions. There's an A and there's a B. Why don't you give this a try? Whoops. On this test, I would highly encourage you not to skip these problems. Because it's... Okay. All right, here we go. So we have a few minutes to work through this. What's the first step we do? All right, oxidation. So this is obviously going to be 1, right? All right, so Cr2O7 minus 2 goes to Cr plus 3. What was this here? So we got a lot of math. 7 times 2, negative 2 is negative 14, right? Minus 2, so we're at negative 12. Divided in half, this is a plus 6. Are we okay with that? Did I do it right? Okay. All right, then the other one must be this pair. So we have H. Okay. Good. H2O2 goes to O2. This is, let's see, we have negative 4, right? So 2 times negative 4. 2 of these, so O or H must be a what? Oh, I got to be honest here, sorry. There is, because that can't even be possible. There is an exception, O2, when it's not diatomic. So this is hydrogen peroxide, right? In peroxide, it's one of the few times that oxygen is only a minus 1. And that was in our notes forever ago. So H is a plus 1 here. All right, it doesn't really matter. So O goes from there to 0. We okay with that? Okay, So we need to start by first balancing things other than oxygen, correct? So we need 2 of these. Everyone okay with that? Next thing is to balance oxygens. This is a 7 right here, in case you thought it was a 2. All right, we balance oxygen by adding what? Water. So we need 7 H2O, correct? Which means we need how many H pluses here? 14 H plus. Is that one? We're good to go now, right? Oh, charge-wise. Okay, so charges, that's going to be great. So we have 14 pluses, correct? 6 more, 20 pluses. Oh yeah, I didn't, oh, I'm sorry. They don't. Thank you. Okay. This thing bugs me. All right, sorry, 14 H pluses, and then minus 2. Thank you for saving me there. All right, so what do I have over here? Plus 12. Over here, I have a what? Got to be careful here. Plus 6. It is just a plus 3, but there's 2 of them. Okay, just like we used the 14 for the pluses, we have to use the 2. All right, so here we need to balance this out. So we have a plus 12, a plus 6, so I'm going to put plus 6 electrons. We okay with that? Okay with that? Okay, so here I just need to add how many H pluses? 2 H plus. All right, everything else is already balanced except for the charges, right? Let me get rid of this so it's not, so we don't get too confused. All right, that part's balanced, just not the charge, correct? So this is 2 plus, so I need plus 2 electrons. All right, then I need to do what to this bottom part? Got a what? Not by 6, by 3. I need it to both equal 6 electrons. So 2 times 3 is 6 electrons. You okay with that? I'll put that in here. So 3. So I don't want to write it over. What's that? 3. And change this to a 6. Are you okay with that? I'm going to cancel this out and just cancel that out. Good so far? Okay. This is so much fun. All right, I'm going to just, I don't want to rewrite everything, so I'm going to take 14 H pluses and subtract 6. So 8 H plus. Are we okay with how I did that? Okay, canceling those out. Plus Cr2O7, 2 minus, plus 3H2O2 goes to 2 Cr plus 3 plus the waters here. I have 7 minus 3. Are we okay with that? So plus 4 water plus, I did. Oh, that's because I'm blind and I did that wrong. Thank you. That wasn't water, that was H2O2. I'm not smart sometimes. Okay, so that is H2O2, not water. I'm sorry. I just glanced and they look the same. So I need the 3. I got those. So over here I have the 7H2O. Usually you can cancel water. That's why I was used to doing it. Plus 3O2. Did I miss anything? No. Okay, that was fun. Yeah, it'll be acidic. All right, this is one we just barely did. This is one that's reversed. You do it this way. You should have done that. Here's a reversed. Here's the steps to do those. Sorry. To solve for grams, set up a picket fence with the given moles. Use moles to moles of electrons, right? So for every 1 mole Cr, I have 3 mole electrons because it's a +3. You okay with that? All right. Use mole to coulomb for every 1 mole. 96485. All right. And then that's this. And then this gives you coulombs, but I need just amps. Whoops. Oh my gosh. I can't write. That was tricky. I need just amps. So amps are seconds, so I now need to eliminate by time, so I got to divide by seconds. So 8 hours, it's 8 times 60 times 60. So that comes down here. So you got an amp. And then, did anyone multiply that for me? 20,800?
28,000.
Okay. So that leaves you with just amps because the seconds were eliminated, and then there you go. So you take your moles times your electrons, essentially, times it by your Faraday constant, and divide by seconds. I will post this. This is very, very similar to this problem. It's the same thing here. This is a 5. Like the time and the moles change. But it's just same setup. Yep, that's the answer. 2.51.